All right, let me give you an expression here. We get x squared minus 9 over x squared minus 2x minus 3. 2x minus.
Could you do this?
Okay. Well, let's look at this kind of as a complete picture first, but yes, we will do that eventually. This is a rational expression, and we are going to simplify it a lot like we did yesterday, and we're also going to find those excluded values. Now, what I want you to do in these problems is simplify the numerator and factor the numerator and factor the denominator. Look at the numerator, guys. How many terms are there? 2. So what can you factor a binomial into? A difference of 2 squares. And who can give me what that difference of 2 squares would be?
X plus 3 and x.
X plus 3, x minus 3. Good. That's the factoring of the numerator. The denominator has 3 terms, so I have options. What's the lead coefficient of the denominator? 1. The lead coefficient is 1, which means you can go directly into the binomials. You got x in the first spots. And then what 2 numbers multiply to get me negative 3? That add up to be negative 2.
Negative 3, positive 1.
Negative 3, positive 1. That's correct. Okay, you factored the numerator and you factored the denominator. Any questions on that? You're going to be doing that a lot, by the way, factoring both. Okay, now I want to get those excluded values first. So what part of the fraction do I look at? The denominator. So I'm looking at the denominator. What can x not be? Positive 3 and negative 1. Now, how do I know that? This is how you set it up because some are not that clear. So I want to set this up to equal to 0. So I got x minus 3 equals 0 and x plus 1 equals 0. So how do I solve for this one? I do what to both sides? Yeah, x by itself by adding 3 to both sides. Don't I get x equals 3? That's why x cannot equal 3, because if x equals 3, what's 3 minus 3? 0. And what's 0 times anything? So do I want a 0 in the denominator? No, so x cannot equal 0. That's one excluded value. The second excluded value, if I solve for x here, I would get x equals negative 1. That's another excluded value. Here's a helpful hint. What is the degree of the denominator? Do you guys remember? What's the degree of the denominator? Someone said it. 2. It's a second degree polynomial because what's the highest power of the exponent? It's 2. So you know how many excluded values I'm going to get? What if my highest power was 3? You get 3 excluded values. Highest power is 4? 4 excluded values. Highest power is 1? 1 excluded value. And that works every single time. But anyway, I got my 2 excluded values. Okay, any questions on excluded values? Yes, ma'am.
Could you have a power, not have a power, and then not get any excluded values?
The only way to do that is if I didn't have a variable in the denominator. So like if I had 3 down here, just 3, there'd be no excluded values. X could be anything.
Could you give us an example of what the denominator would look like if it was one excluded?
Yes, we're actually going to get an example later. Yep, we'll get an example of 1, 2, 3, 4. We'll get all of them. Okay, but that's one part of your homework. The other part is to get this as simple as you can. Can anything cancel out in this fraction? X minus 3 over x minus 3 equals 1 over 1. Anything else cancel out? No. The only way to cancel out x plus 1 is if I had x plus 1 up here. The only way to cancel out x plus 3 is if I had x plus 3 down there, and I have neither of those situations. So my simplification is x plus 3 over x plus 1. That's it. That's simple as it gets.
Isn't that kind of what we were doing?
Yes. So this is review. Which I like. Sorry, I think I skipped that one. Okay. Oh. Just when we thought, well, I got a hang of this. Let's go to this example. 3x squared minus 15x plus 12 over 6. Okay, that's a lot. What do I want to do to the numerator and denominator? Factor it. What was your first step in any factoring problem? Find the... How many times have I said that? Can anyone estimate?
1,000,000. 420.
Okay, good. It's about 30 times. 30 times I've said that. Maybe after the 40th, it'll really get nailed down. What's the GCF of the numerator? I'm just dealing with the numerator. 3. What is left behind when I factor a 3 out? X squared. What's the rest? Minus 5x plus 4. You guys agree with that? Okay. Is this factored completely? Is this as far as I can go, or can I go further? What's inside the parenthesis? A trinomial. What's the lead coefficient? 1. So what can I factor that into? So the 3 is still out there. I got an x in the first spot. What two numbers multiply to get me 4? They add up to be negative 5. Negative 4, negative 1. Yep, negative 4, negative 1. That's my numerator. Is it factored completely? Yes. This is what you did this morning. I'm going to write, that's like where I write my work. Maybe I'll just separate it. And then here's where I'm going to get my next step. Okay. Numerator has been factored. How do I factor the denominator? Well, first, is there a GCF?
Yes.
What is it?
6.
It's 6. 6 is a GCF. 6 comes out. What am I left with? X squared.
Plus 4x minus 1.
Okay. Can it be further factored? Can this be further factored? Yes. It becomes another binomial times a binomial. And what goes in those spots? So in its fully factored form, I get that. I'm going to write it over here. 6 times x plus 5 times x minus 1. Ooh, that looks nice. Okay. Did I factor the numerator? Did I factor the denominator? Completely? Okay. I want to find my excluded values first. Where do I look? The numerator or denominator? Always the denominator. What are the excluded values?
Negative 5 positive 1.
X cannot equal negative 5 and x cannot equal positive 1. So 2 excluded values. Wait, how did I know I was going to get 2 excluded values?
Second degree.
The denominator's degree was 2. So 2 excluded values. That makes sense? Okay, once I get those excluded values, it's time to simplify. Chop things up to make it smaller and easier to deal with. Ma'am, before I do that.
Didn't you say if you had like that 6 that's in front of the x plus 5 and the x minus 1, doesn't that have something to do with it, isn't it?
Oh, yeah. Okay, technically, in order to get, are you talking about excluded values? In order to get these two, I technically did this. I did x plus 5 equals 0 and x minus 1 equals 0. I solved and I got here negative 5. And I solved here and I got positive 1. You agree with that? I just put my little slashes. My other equation would have been 6 equals 0. Is that true? That's never the case. That doesn't count. You don't count that number because you can never make it equal 0. Can you make x plus 5 equal 0? Yes, if x equals negative 5. Can you make x minus 1 equal 0? Yes, if you make x equal 1. Can you ever make 6 equal 0? Nope, can't do it. So it's not an excluded value. We'll leave it alone. Okay, what cancels out here, guys?
X minus 1.
That's nice. What else cancels?
6 over 2.
Yeah, you get 1 over 2. 1/2 there. So what's left in the numerator? X minus 4. What's left in the denominator?
Times x plus 5.
Okay, now, ladies and gentlemen, we did this yesterday. How many of you feel a little more comfortable with this today? Look at that, all according to plan.
Yeah.
Okay, yeah. Good, everyone feels more comfortable.
Yay.
Good. Just when you felt comfortable, I give you this one. Go. It looks like it, but no. Yeah, I think it was that PQR. This one has P and Q. You're welcome. All right, write this problem down, folks. You're going to do it just like you did every other problem. You're going to factor the numerator and factor the denominator. What do you look for first? GCF. What's the GCF of the numerator?
9Q.
I think it's 9PQ. 9P, and be careful with all these numbers and variables, they're very similar. 9PQ. What was left in parentheses? P plus Q. Yes. What about the denominator of the... Wow. What about the factoring of the denominator? Sorry? 3P. Just 3P. And we're left with P, good. P squared minus Q squared, I think. So just be careful with that. That is...
Can you factor
What?
the denominator?
Yeah, can I factor it more? Yes, you can. Isn't P squared minus Q squared a difference of 2 squares? What would that factor to, by the way?
3,
Yeah, you got 3P.
3P, and then it would be P plus Q and P minus Q.
Yep, P plus Q, P minus Q. That's hard to say. Again, I'm going to rewrite it, because again, that's where my work is coming from. Okay, that's everything factored. You guys agree with that? How many excluded values should I anticipate? 3. Okay? Yes, ma'am.
But,
Here's the fun part. It's going to get fun.
so it's not going to equal.
Okay, hold on that. Are you talking about the excluded values? Okay, ready? What can this whole denominator not equal? 0, which means that 3P, P plus Q, and P minus Q cannot equal 0. Okay, ready? I'm going to write it down. 3P equals 0. P plus Q equals 0. P minus Q equals 0. This is a cool problem. It's like, wait, how did that work out? It works out, and we'll test it to make sure. What would P equal here?
0.
So what can P not be?
0.
Cannot be 0. That's first excluded value. Okay, what about here?
Which one do you like?
Yeah, you're like, which one should I solve for? It doesn't matter. I'll just solve for the first one, P. So what do I do to get the Q out of there? So P does not equal negative Q. That's another excluded value. And you're like, wait, what? Let's look at it in just a moment.
Why can't they make it a G?
I don't know. And then who could solve for P on the third equation? P cannot equal positive Q. Okay, whoa. How many of you understand that P cannot equal 0? We get that, right? The letter P cannot be 0. What does it mean by P does not equal Q?
Whatever number Q is.
Whatever P is, Q cannot be the same thing. And what does P does not equal negative Q mean? Whatever P is, Q cannot be its opposite. All right, ready? Ready? Let's pick some numbers. Jake, your favorite number is 7. 7. Can P and Q be 7? Can they both be 7? According to the excluded values? No. Ready? Let's see if that really works out. What's 3 times 7? 21. Ooh, see, that works, doesn't it? That's okay. What's 7 plus 7? 14. Ooh, see, you got 21, 14. That works, doesn't it? That's good. What's 7 minus 7? 0. What's 21 times 14 times 0? 0. Do you see how P and Q can't be the same thing? Because if they were the same thing, what happens right here? You get a big fat 0. That's no good. But we also said that P cannot equal the opposite of 7. What's the opposite of 7?
Negative 7.
Okay. P equals 7 and Q equals negative 7. Is that what I'm saying? All right, what's 3 times 7? 21. That still works. What's P plus negative 7? 0. Can I have that? I got 21 times 0 times I don't care what it is. What are you going to get? 0. So you see how these are your excluded values? It's a little weird. Wait, are you asking if it's going to be on the test or quiz?
Just like this problem like this, where it's like a variable cannot equal a variable.
That's a good idea. I wasn't thinking of that. Wow. Thank you, Parker. Thank you, Swole, for recording that.
Thank you.
No, yeah, I'm going to put one of those.
Wait, you didn't simplify it.
Got so excited with the P equals Q and not equaling Q. Okay. This is our factoring. So here's the easy part. If you factored correctly, what can cancel? What can be canceled? P plus Q can cancel out P plus Q. That's good. Okay, good. I'll do it one at a time. Can you do the 3 and the 9? 3 and 1, right? And then what about the P's? They also cancel out into 1 and 1. What are you left with in the numerator?
3Q.
3Q. What's left in the denominator? P minus Q. Can you cancel out those Q's?
No.
No, because one set, or Q's being multiplied, Q's being subtracted. Can you undo subtraction with multiplication? No, don't get into that realm. You're done with that. That's fun. That's a good problem. Anyway. I'm gonna scale it down now. Minimize it. I want you, listen to me, to find the excluded value. Just find the excluded value first. We'll deal with the rest after. What am I looking at for excluded value? Can I factor any of that? No. So there's not a difference of 2 squares on either one. So you're done factoring. So this is what I do. Y minus x equals 0. So what is your excluded? Y does not equal x. That's your own. Wait, there's only one excluded value. How does that work out? What's the highest power, or what's the highest, I should say, what's the degree of this polynomial? It's 1. One excluded value.
The other way and do X. So for the simplified version.
Yeah, you can say x cannot equal y, because y cannot equal x and x cannot equal y are the same thing. So you can do it either way. So you could say that. Yeah, you're allowed to do. Okay, excluded value, you okay with that? Parker, that was your question. Is that on the test? It will be.
Oh, but if you.
Oh, that was easy? Awesome. Oh, yeah, we're going to get simplified, but I got a question. Can you wait? Yeah. There you go. Thank you. Okay, hold on, Brandon, because I don't want you to miss this out. Okay, the way it's written, nothing cancels out. You cannot cancel out the x's. You cannot cancel out the y's. But, man, if I just did this, right, couldn't it cancel out if I just switch those around? Is that true?
No. Yeah.
I mean, if I could, like if I just switched x and y, would it cancel? Yeah. Man, I wish I could do that. You can't. You can't. Okay, hold on. If I switch these two around, I heard it right. You'd get negative y plus x. And then you still get y minus x. Can those cancel out? Math lady? Yes, ma'am? No, you said it.
No.
Okay. What can I factor, and you can do it 2 ways, but what can I factor out of the top, the numerator? I can factor out a negative 1. Okay, ready, guys? Some of you aren't going to look and you're like, wait, what did you do? Okay, ready? If I factor out a negative 1, what's left here? Y minus x. Now let's see if it works. What's negative 1 times y? What's negative 1 times negative x?
But what do you have to do? I thought you had to do that.
Great question. Y changes to a positive. X is a negative in the numerator and denominator, so guess what happens?
If there's -1.
Those cancel out. The simplification is negative 1. This is equal to negative 1. That's why, because I like negative 1 better than that. Don't you? If I gave you a math problem, Jack, and I said you get to choose between that and that, which one would you choose, honestly? That. Awesome. Good answer. There's no way to get the wrong answer. Watch. This right here, remember I changed it to this? You guys remember what I changed it to? Does this equal that?
Yeah.
You sure? Because if it doesn't, I did something wrong. We got to go back. What's negative 1 times y? Negative y. What's negative 1 times negative x? Positive x. So I didn't change the value, but I did change the way it looks because I like that. Do you like negative 1? Or would you rather do it with x minus y over y minus x?
Can't you just roll cancel or something like that?
You want to make them cancel.
Exactly. So since like it's just the problem, you could just do cancel y and x, and then get like.
No. Don't do that. Let's do it on another problem. How about that? Let's get more practice. This is good stuff. Right, Annie? Molly? What do you think? It's good stuff. See, she's smiling. Josh? Look at that. I like that smile. I know what he's thinking. Cole? Look at that. See, I didn't even say anything. Cole even knew. And he knew what we were talking about. This is good stuff. Elizabeth, that's kind of a smile. Or is it like, it's a skeptical grin? So that's like...
You have to make Sydney, we call her sad because sometimes she's sad.
Don't smile for
You have to make her glad.
She's glad.
And then Mr. was
How about let's factor this out? The numerator I'm looking at saying to myself, I'm not sure about the numerator. I can factor the denominator. Yeah. The denominator would factor out. What two numbers multiply to get me 8 that add up to be negative 6?
4 and 2. Negative 4.
Okay, good. Negative 4, negative 2. You got to give me that sign. Oh, and I still have 4 minus n up top. All right, just get me the excluded values. How do I know that there are 2?
Because
The degree is 2, so the second power. It's the highest power 2. All right, what are those excluded values? N cannot equal 4 and n cannot equal 2. Any questions on excluded values? That's okay. Yeah, I'll go slower. Told you I could do it.
one more report card.
Yeah.
Wait.
Yeah, fourth quarter.
Is there any?
We have
Is there anyone who can switch the denominator around and do the other problems? Make n minus 1?
That's not cool. Can't do that. Wait, yes you can. But hold that. Yes, you can. And hold, pause.
No, it's
Okay, first, we got those excluded values. Now we try to cancel. Now, do you notice here I got 4 minus n, and I got n minus 4. Those do not cancel out the way they are, but I can do something to make them cancel out.
For the when you're doing the finding the excluded value, when you write n minus 4 equals 0.
N minus 4 equals 0. So then
And
you
then-
add 4, you get 4.
Oh, okay. You wouldn't have to switch it to the opposite.
Yeah, okay. If you just look at it here, you're switching the opposite of negative 4 to positive 4.
Right.
But when you're working it out, that shows you why you're allowed to do that. Because you really added 4 to both sides, right? You got n equals 4. So that's, so
You
yeah,
wouldn't have to change
don't
that
switch it, yep.
value.
Mm-mm.
Okay.
Okay. Yes, sir?
Why exactly do we need to find the excluded values?
Yeah, excluded value. Good question. If I find the excluded values now, when I'm solving equations, because we're not into equations yet, but when I solve this out and I got n equals 4 as one of my answers, I know it's not my answer. It's a false answer. Why? Because n cannot equal 4. Even though mathematically I work it out and I write n equals 4, that I solved it, Mr. A, but nope, can't be that because then I'll make the denominator equal 0. That's bad. No, actually like next week. Yeah, we're going to get to that. Yeah. And then, yes, 2 years. And then after that. And then after that. Okay, sorry, I'm done. All right. Do you guys realize that if I factor out a negative 1, please listen, because some of you are going to get really confused. Instead of saying 4 minus n, can I say negative n plus 4?
And then do the greatest.
And then if I take out the negative 1, what do I get up top? Negative 1 times n minus 4. So cancel. Those are done. This is what I have. Does anything cancel?
Yeah.
Yes and yes. What's left? There's no n anymore. So negative 1 over n minus 2.
I know that.
Wow, that's pretty right.
And see, here's a question that's so common. I get it, and here's, I hope, the answer that's valid for that. Would I want to deal with this or with that? I mean, be honest. Which one do you want to deal with? Top or bottom? Bottom or top? I want to deal with the bottom. And I'm telling you right now, by the end of this week and into next week and the weeks after, I like the bottom. And so we need to get it to that as best we can. Yeah, I don't think they cover this in standardized testing. Anyway, begin. I need all of you to get this one right. Oh. Ma'am. You may. You can use your calculator for the rest of the year.
Oh, you start that at the beginning. We're allowed to use it for testing, mister? Or are you doing putt-putt?
I'm very behind. Like, my mind doesn't catch up to
Are we
things.
allowed to use our calculator?
Yeah, you can use your calculators here.
Testing.
Oh, no, not for testing. That's not my requirement. That's the state of South Carolina, and all states relate to that. Okay.
Wait, so if I'm in North Carolina,
Some may, I don't know about North Carolina, but I know South Carolina, no. And a lot of them actually don't on these tests. Maybe. I don't know.
You can drive when you're
It's used to
14 in
help you
Iowa.
like boost your grade or if you bomb it.
That's like not very good.
No, it doesn't do either of those, but thank you for your input. It helps teachers and the administration to see how you guys are doing compared to the nation.
so it doesn't
So if we
matter.
like our
So like, Sarah, are we teaching you well in Algebra 1? Well, I don't know, because I don't know what they're teaching down the road. But if I do standardized testing, I'm like, okay, they got tested, you guys got tested, and how did you do in comparison? It helps us to see how we're doing. And it doesn't count against your grade or for your grade at all, nothing. No effect. Not yet, not yet. They'll look at it in junior year of, they don't care. They don't care right now. SATs and ACTs that's junior year. They will care about that, but that's later.
SATs are so hard.
Okay, I will.
Okay, sorry. The numerator can factor out if I take out a 6, 7 minus D. The denominator can also factor out, and that would give me D, and then what two numbers? Negative 7 and positive 2. Okay, what are the excluded values? That's what you want to find first.
7 and negative 2.
So D cannot equal 7, and D cannot equal negative 2. Good, excluded values are pretty clear. What's the simplification?
negative 1 over b plus 2.
6 over D.
I think you're close. Okay, hold on. Could these two aren't they super close to being canceled? Okay, they are super close, but they are not exact. How can I change this so that it looks a lot like that?
Negative 1 times
Okay, ready? Watch this. This is what happens. Ready? Listen, this is what's going on. I factor out a negative 1. So the negative 1 comes out. What does it do to the 6? Makes it negative 6. And then basically what happened was these switched. Isn't that basically what happens? They switch. So it's D minus 7. So can I cancel these out? Yes. Now they cancel out. What's left?
Negative 6 over D plus 2.
Done.
Nice.
Whoa.
Very solid.
How many of you got that one?
I got it after you wrote it, Mr. One.
Well, when you took that negative 1, what happened with the 6 that was there and that negative 1 that came out? They became negative 6. Because negative 1 times 6 is... No, it started off as positive 6. And then I changed the sign. Prove it.
Negative 1 over A, Mr.
I like this problem because it's like the ultimate tough problem.
Ultimate final form.
Duke, champions this year. Called it.
UCF.
Oh,
UCF almost beat them.
so close yet so far. Although I felt bad for them because they had 2 chances to do it and they just rolled out. But that's what was determined to happen.
Just
So.
watch, Cole.
My dad, when he like missed the alley, my dad was like, "Oh, they're screwed. There's no way they're coming out." But they went by like 2-1. They were down up by 1, and UCF had 2 shots, like 2 points.
Yeah, it's sad. I feel bad for them. I do. But Duke's in it. They're gonna win it. They had their chance. Now it's done.
I mean,
Yes.
All right. How many of you are done? Good. One person is done, so only one person should be talking. Oh, no one is done, so no one is talking. Even better. Okay. Is anyone stuck? Okay. Can we do the factoring? What's the GCF at the top? Okay, you can do bottom or top first, but I'll do AC. And then what's left? A minus C. And then on the bottom, what factors out?
A squared C.
A squared C. And what's left? C minus A. Okay, yep.
Then on the top, can't you just make the...
Hold on, don't cancel out anything until you find those excluded values. I need to do that first. Find the excluded values. It's a good question. What's the degree of this polynomial? 4. What's the degree of this term? You add up those exponents, you get 4. What's the degree of this term? 4. So how many excluded values could you have? Technically 4. We're going to see why we only get 3 though.
What, Mr. A?
Is that possible?
On the
Yes, it
last
is.
problem, when we had the highest degrees
Yep.
of 3 and both of those, why did you not just keep 3 on this one for the highest degree?
Well, what's the degree of this one first of all? 4, because you got 2 plus 2. What's the degree of
Why'd
that?
you make that one 4?
Oh, because it's 3 and 1.
Right. What?
So the degree 4. So the whole degree of the whole thing is just 4. You keep the highest one, and there's a tie. Right? So
But if you get 8 and you get a degree of 4 and you know the other one's 4, does it really matter?
well, you do want to check both just in case that was 5. I mean, you just check. Okay. Yes, ma'am.
Are you for the denominator?
Yep.
Right.
Right. Here's what I'm going to do. This times that equals what? 0. Good. So A squared equals 0, C equals 0, and C minus A equals 0. Those are your 3 options. And you're like, wait, I thought you said there was 4. Yep, there are 4, but 3 versions. Wait. Okay.
But then A would just be the same thing. So
Because what do you do to solve this one? Square root it. Now, you would get A equals plus or minus 0. That's 2 numbers. But what do they actually come out to be? Just one thing. A cannot equal 0. What can C not equal?
0.
And then what's over there?
C cannot equal A.
Good. C cannot equal A. C and A can be the same number. If they are, that's bad. So technically there are 4 excluded values, but 2 of them were the same, so you just write it once. What's your simplification, Braden?
AC. Isn't it
How about this? Let's go step by step. What can cancel?
A minus C?
Okay, these could cancel, but not the way they're written. Okay, you switch them, but what comes out when you switch it? So if you switch these two, you're allowed. You come out with a -1. So then I get C minus A. You guys agree with that? Okay, so now what cancels out? C minus A. C minus A. What's left here? -1 over A.
Whoa, I did not get that at all.
That's okay. How many of you got -1 over A? Oh, whoa. Even if you didn't. Okay, awesome. That's a hard problem.
Wait.
Behold your homework. Work hard, guys. I give you a reward. Bye-bye, Swivel.